They can come up and I'll mark them late after class. So. All right, so up on the board here, does anybody got any questions before we start? Do I have any K-State fans, I guess I meant to ask. K-State fans, I just wanted to apologize in advance for your loss tonight. So that's why I wanted to see what K-State fans we had. Okay. So the Iowa State plays K-State in the Big 12 tourney tonight. So they had a big upset last night against Texas, but they're going down today. So, all right. So how has trade changed over time? And so one of the ways we can look at this as trade as a percent of GDP. So we haven't talked about GDP yet for the most part, but that is the dollar value of exchange that goes on. The number of times cash registers ring in the United States is about $24 trillion, depending on what measures you're using. So kind of be thinking in your mind 20-something trillion. And so of all of that economic activity, how much of that is us buying stuff from other countries and other countries buying that stuff from us? What were imports? Buying stuff from other countries or selling stuff to other countries? Imports. Buying stuff. So here we go, 1960, 4% of all of the stuff we bought was from foreigners, and now we're up to 15% of all the stuff we buy. The stuff we sell, again, around 5% in 1960, and now it's floating up here around 13%. So exports are smaller than imports, leading to something we'll talk about later called the trade deficit, right? So we buy more stuff from the rest of the world than what we sell to the rest of the world, and that's known as the trade deficit. Turns out to not be a big deal, but sometimes people make it a big deal, especially the former president and potential, he is the presidential candidate, I think, well, maybe not officially, Trump, who says some dumb stuff every now and then, and this was one of them when he made a big deal about trade deficits. And so trade deficits, in my opinion, aren't that big of a deal. It might be something to peek at, but in the case of the United States, the fact alone that we buy more stuff from the rest of the world than what we sell to the rest of the world actually isn't a big deal. So we'll talk a little bit more about that actually in future chapters down the road. So here, just to kind of show growth of trade, and then here is our trading partners. So as you can imagine, transaction costs and transportation costs play an important role on who your trading partners are, right? So who are our top two? Neighbors to the north, neighbors to the south, right? So you have to truck stuff back and forth or get it back and forth. And then China, over time, has been a large trading partner. And then here's the rest of the list. So all other countries, though, dwarfs all of our main trading partners. So we really kind of spread the love, so to speak, around the world on who we buy and sell with. So that's kind of a glimpse of what international trade looks like around the globe for the United States. Any questions or comments there? All right, well, let's continue on with our story from yesterday. We had an exciting story building here of trade between two countries. And I'm just going to be, if you weren't here yesterday, you should draw this. Otherwise, you guys can just go with what you have drawn and maybe try to absorb what I'm doing without having to try to draw it too. Maybe some things will stick a little bit better. So we have the USA to the left, Japan to the right, and we're reflecting the production possibilities in each country. And so what we drew yesterday was if the United States threw all 2,000 people at producing cars, then they could produce 16,000 cars, measuring those in thousands. If they devoted all 2,000 laborers to food production, they could produce 8,000 cars, or food, 8,000 units of food. And so anywhere, they could also split it up. So this then represented the production possibilities curve for the United States, which means they can be anywhere inside the frontier here, this edge. They can be on the edge, but they can't be outside of the edge. Why? What caused them to not be able to be outside of that line?
That is the maximum amount of what they can produce.
True, but not enough information. What is the limiting factor? Thank you, Tim. What he said is true. He said that's the maximum amount. My question is, why is it the maximum amount? Let me get somebody back here. Look at your notes from yesterday. Yeah. Yeah, resources and technology. So we only have so many resources. In this case, again, this is an economic model, so we just had 2,000 people was our resource, right? We had one resource, and we're just saying, if that's all we got, this is all we can do. We can dream about being out here someday and hope to get out there, but we don't have currently enough resources and technology. And this is one of the big things about economic growth. As there is advances in technology and the population grows and people build more computers and more machines and more tractors, then this causes this line to do what? Shift out or in if there's more technology and more machines and more tractors? Out, right? So what we're doing is we're increasing the possibilities. This is really economic growth that we'll kind of tie back to later, tying it to GDP. But here, conceptually, if our new production possibilities looks like this, gosh, I can have more cars and more food, right? I'm better off. So it's kind of signaling the material well-being of society through the amount of output that we can get. All right, and then we did the same thing for the Japanese. And we learned that if they threw all 1,000 people at food production, they could have 5,000 units of food. If they threw all their 1,000 people at car production, they could have 25,000. Or they could be anywhere in between. And so this represented their production possibilities curve for the nation. All right, and so where we left off was now looking at the cost. And so what did we leave off with in terms of who had the comparative advantage in food? The US. So when we looked at the cost, at the trade-offs, so the opportunity cost, in fact, I'm going to write it out because we're going to do it again anyway. Opportunity cost of one food in the USA is, how much was it? 2 cars. Don't forget the labeling here, because it's not $2. They have to give up 2 cars to get one food, and the opportunity cost of one food in Japan was how much? 5 cars. So it's more costly for the Japanese to make a food because they are so good, relatively speaking, at making cars. It's kind of costly for them to make a unit of food. So therefore, the United States has a comparative advantage in food. They are the low-cost producer. All right, well, let's do it again here. So the opportunity cost of one car in the USA is what? What is it? 0.5, good, yeah, so 1/2. How'd you get that?
Well, since it was dividing by 2, both sides by 2, and try and get one car.
How are you getting the divide by 2? I mean, I think you got it. I just wanted to be able to articulate it. Honestly, if you can articulate it, you've got it, right? Then you've got the economics, not just the math. Does that make sense? This isn't math class, this is economics. We want to tell the story of what's going on. Did you have it?
Divided by 4.
Divided by 4, why?
Well, you divide them, so to get the 2 cars, you divide it by 4, so you get 1/2.
Okay, we're getting closer. Why did we divide it by 4? What information was I using here to get my 2? I like that you guys are trying to reverse engineer, so that's probably a good idea. Let's reverse engineer how we got the 2 in the first place, which we did yesterday, which some of you should have in your notes on why we divided by 4. What's the trade-off? Yeah.
I don't know what the answer to that question is, but isn't it 16 divided by 8?
16 divided by 8. Okay, and why, Tim?
Because these are the maximum amounts that you can produce of either cars or foods.
Okay, we're getting closer. So Tim is taking this approach, which is fine. Let me help you out a little bit. I could be at point A, correct? Is that a possible production point? Yes. I could be at point B, correct? Yes. So now tell me about the 16 divided by 8 thing.
16 is the maximum amount that you could produce by cars without producing. 8 is the maximum amount of food that you can produce without producing any cars.
Okay, and now we got to keep it coming. So you put my equation goggles on. What did we do yesterday with our equation goggles? Go ahead, Jesse.
Well, the way I have it written down is we took 4, which was the average food one person would make.
Okay, you're back to our productivities, yeah.
Yeah.
For what?
Food
For food.
equals 8 cars.
Okay, let's pause there for a second. Look back in your notes. That's how we generated this, right? From your productivities, it said one, and Jesse said it right. 1 American on average could produce 8 cars or 4 food. Now let's use Tim's. I'm going to do something simultaneously, hopefully not to screw you up. Using Tim's thing, we could have 8 food, point B, or that's equivalent to 16 cars. Everybody with me? Now, I don't want the cost of let me jump to here. I'm going to kind of, since we got that laid out now, I don't want the cost of 8 cars. I want the cost of 1. So what do I need to do to get a 1 over here mathematically? We got to use our math tools here. Divide by 8. What I do to one side of the equation, I got to do to the other side. 1 car equals 4 eighths, or Justin? 0.5, right? So he gave us a half. That's how we got the half. Or if we use Tim's method, I don't want the cost of 16 cars, I want the cost of 1. So what do I got to do? Divide by 16. What I do to one side of the equation, got to do the other side of the equation. Tim, what is the cost of 1 car? 0.5, or 1/2 of what? 1/2 of a food. So this is 1 car equals 1/2 of a food.
Would we be doing the same with Japan?
We're going to do Japan right now, so we'll see. What's the answer for Japan?
We're getting 1 car, right?
1, yes, 1 car. Right, same thing. My little ... is actually the little hashtag bringing down what I said above. So what do we get here? A 5th, yeah. How'd you get it?
Because it was 25 cars.
Okay, so 25 cars is how, I'm sorry, give me your name again. Nathan. 25 cars is equal to 5 food. Why? Because I can be at either point. I don't want the opportunity cost of 25 cars. I want the opportunity cost of 1 car. So divide by 25. What I do to one side of the equation, I got to do to the other side of the equation. 5 divided by 25 is 1/5. 1/5 of a food. Let's put little stars up here for the Japanese so we don't get confused. That's the foreign country. Who's better at producing cars?
US.
US, why?
Because 1/2 is bigger than
1/2 is bigger than 1/5, but how do we measure who's best? Do we want to be bigger in this case, or is this a game of golf? Anybody get that little inside thing? Do I have any golfers in here? Should have some golfers, right? Maybe not on the golf team. Oh, there's a golfer. So game of golf. You want a high number or a low number? Low number. Why do I want a low number here? What is that 1/2 of a food and 1/5 of a food representing for each country? How much you lose, or the cost, right? So the cost, the opportunity cost of a car is 1/2. The cost of a car in Japan is 1/5. So you said it right, which I was glad, by the way, that you got the ordering right. 1/2 is bigger than 1/5, but that means these guys do it at a lower cost, right? So since Japan can make cars at a lower opportunity cost, it has the comparative advantage. I'll write it out. You guys should have it in your notes from yesterday, but a comparative advantage, that's the CA. A comparative advantage in cars. So, the US has a comparative advantage in food. They are the low-cost producer of food. Japan is the low-cost producer of cars. And so if we're setting up some sort of international trade deal, who should do what? So we go here. Give me your name again. Arthur.
Japan should sell cars to the US, and US should sell things to Japan.
Good. So we're going to specialize in the thing we're good at, right? So this is setting up what I put in your notes on, I believe it was maybe Tuesday when we started this off. Reasons for trade is that countries should trade for things that they have a cost advantage in. Now we've laid out the case here that even when the deck is stacked, who had an absolute advantage here? Japan or the US? Absolute advantage. If you look back to those productivity numbers. Japan was better at both things, right? They were leaner, fitter, faster, more productive, whatever. They were more productive at producing both goods. And so what I teased you with is that if Japan is better at everything, why would they ever want to trade, right? Why would they ever want to trade? So you can imagine, here's kind of an old example that was in textbooks and other things, but I think it works. So suppose you're an attorney and you're really good at being an attorney, but you also happen to be an awesome typist. You can type like 150 words a minute, right? You know some people that do that, but like they don't even think about it. Well, that's this attorney. If an attorney is a better typist than his assistant, why would he ever hire an assistant, right? What should he be spending his time doing, even if he's a great typist? Practicing law, right? So just because you're better at something, more productive at something, doesn't mean you won't have gains from trade. So if he is more productive, relatively speaking, compared to the assistant, now if we take the assistant's legal training, maybe they had an undergraduate degree in business law or something like that, pre-law, so they have a little bit of legal training, but he is a full-blown attorney, then which one should be doing what, right? And so there's advantages to these two people working together so that the attorney can focus more time on law and less time on typing, even though he's better at typing. Does that make sense? So that's this whole philosophy of comparative advantage, which is the cornerstone of why we get awesome stuff from free markets by letting people just exchange with each other. We don't get a win-lose situation like a lot of anti-capitalist people, anti-market people say, oh, the rich are taking money from the poor, that's why they're poor. That's not true. I've got evidence, we're doing it right now, that when people voluntarily exchange with each other, it's a win-win. It's a positive sum game to where both parties can win through exchange. All right, and that's what we're really laying the case out here in the country example, but the same thing applies to market exchange, kind of more of a microeconomic concept of why do we want to trade with each other. The premise is the same. All right, so any questions so far? All right, so let's continue our story here. So this is, what we conclude from this. The USA should specialize in food production and trade for cars. Japan should specialize in car production and trade for food. All right, so now I'm going to see how far we can get to measure the gains from trade. So let's call this showing the gains from trade. Showing the gains from trade. Let's assume some starting points. So to start this little analysis off, we're going to assume that without trade, the USA is currently at 8 cars and 4 food. And Japan is at 10 cars. And now I'm going to turn to you guys. Blank food. So this is, you're going to see a homework problem or a test problem like this. So let's say, okay, 5, 10, 15, 20. You guys have it a little nicer in your thing. 5, 10, 15, 20. So I want to put Japan at 10 cars. If that's true, how much food are they currently at? Who's got their math hat on? This is a math hat here again, Simon. 2. Why? How'd you get that? Okay, so 1 car does equal 1/5 of a food. I'll give you that. I think you're kind of going down maybe a more difficult path than we need to. Let's start with the slope. What is the slope of the production possibilities curve for Japan? What's the slope? Come on, people. I know some people know it. We've got a concerned, worried look on Tim's face, but he's being brave. All right, go for it. 1/5. No. But Tim gets an extra credit point because he was the only one brave enough to actually, with a concerned look, I love your bravery and I like to reward bravery. So Tim gets an extra credit point for the wrong answer. Sometimes that happens in my class. What is the slope of the production possibilities curve? Yeah. 5. Zach, right? Zach is absolutely wrong as well, but I'm feeling generous, so Zach, you get an extra credit point. What is your last name again? Last?
Hammer.
Cameron?
Hammer.
Hammer, that's right. All right. You guys who came in late, come and see me so you can get your attendance. We took it at the beginning of class here. All right, who else wants to take a stab? Oops, Simon wants to redeem himself. All right, I'll look for some redemption. What do you got? -5. Ding, ding, ding. Simon with redemption, but no extra credit for the right answer. Sorry, but you got some already. -5. Zach, you were so close. So close. All right, so how do you guys do in your head, like calculate the slope? What's your little formula? Maybe you got taught in 7th grade or something. Rise over run, that's the one I like. So rise over run, you might be thinking, delta y over delta x or, something. But rise over run usually works, right? So as long as it's a straight line, rise over run works. So the slope is rise over run. And if we move from any 2 points, let's just take these 2 points here. I'm falling how much? I'm falling from 25 down to 10, 15. So I'm falling though, so the rise is negative. That's where the negative number comes out. And then I'm running, I don't have it. That's what I'm trying to solve for. So let's try another one. I got this number and I got this number, so if I fall 25 instead of 15, how much am I running? 5. Now I got it. 25 divided by 5 is a -5. So the slope is a -5. Now, what does that look suspiciously like on this middle column of the board? What does it kind of resemble up there? It's not perfect, but 5 is the slope. -5 is the slope. In the middle part of what we wrote earlier, what is that kind of resembling here? I'll give you a little hint.
The opportunity
Opportunity cost
cost.
of food in Japan is 5 cars. So remember we were doing the trade-off thing? The trade-off thing is related to the slope. That's what the slope thing is a trade-off, right? But now we're telling a little bit different story. The Japanese can always trade internally, production. If they give up 5 cars, they can get 1 food. If they give up 5 cars, they can get 1 more food. If they give up another 5 cars, they can get 1 more food, meaning this number is 3. You got it. We had to spend 5 minutes working on it, but we finally got there. So 3. Now, I see a couple concerned looks. We can always double check our work. Down 15 over 3, 15 divided by 3 is 5. Down 10 over 2, 10 divided by 2 is 5. It works, right? So rise over run, no matter where you pick these points, the slope is constant along a line. All right, so what is the slope of the USA's curve? Yeah. 4, no. Yeah. Oops, sorry, I was going back even a little bit further. Give me your name again. I need your name again too. Joshua. Cole, what did you say it was? -2 is correct. Yeah, so -2. Again, rise over run. Here's the only numbers we have. down 16 over 8. So we get the slope is equal to down 16, negative 16 over 8. 16 divided by 8 is negative 2. All right, so now we have kind of a fun fact here related to econ. Let's call it Russ hack, Russ's econ hack. That will come in handy on your homework and test. So, econ hack. The opportunity cost of whatever is measured on the horizontal axis the opportunity cost of whatever's measured on the horizontal axis is equal to the slope of the PPC. It's actually the opposite of the slope, but I kind of gave up about 15 years ago adding that in because most of us aren't math geeks and you probably don't care anyway. I did care about the negative sign. Hopefully I hammered it enough that what we did earlier. But here we're looking at the United States. Food is being measured on the horizontal axis. Therefore, the opportunity cost of food in the US is 2, which is equal to the opposite of the slope, but 2, right? So the slope and the opportunity cost are connected. All right, any questions on that? So this is kind of a little cheat way to look at things. So anything where if we're putting on, roses and honey, if this is roses up here and honey down here, the opportunity cost of honey is always equal to the slope of whatever the line is, right? You kind of got it right away. As long as you still got to be able to do the rise over the run business. Okay, so now we've set the stage, except we haven't put in what I gave you before. So cut this baby in half, call it 8 and 4. So this is point A, and this is point A star. So the starting places without trade are point A. So without trade, each country's starting at point A. By assumption, we didn't derive that, I'm just giving it to you. But now we've learned that they should specialize in what they have a comparative advantage in. So, which direction should the USA start heading? Downward or upward? Downward. So as they start to specialize, they're going to go all the way down. Now, in the real world, should we fully specialize in food and not make any cars at all? In the real world? Probably not, especially, I used to not believe that as much until, honestly, COVID and the supply chain and computer chips and us being kind of reliant on China for so much stuff, and now China turns out to not be as good of a trade partner and has humanitarian concerns and other things. So I'm a little more of a believer in maybe not going to full specialization. But remember, this is an economic model, not trying to tell all of reality. All of reality is like crazy, right? So I haven't told some of you, and maybe I told this in micro, but I think it's worth saying again. When I say the word economic model, when I was in your seats years ago, I used to think of a little model car. Like I had the model General Lee car and from an old TV show. And so the model car, I knew wasn't the real car, right? I'm not dumb. I mean, I knew that the little plastic 12-inch model car that I glued together. How many of you have done some models like that? Model car, model train, model plane, whatever, right? You know that it's not the real thing, but yet it gives you an indication of what the real thing is, right? You open up the little hood and there's a V8 engine and you close it, it's got 4 doors. You peek inside and you see that the steering wheel's on the left-hand side because we're not in Britain and it's on the right-hand side, right? So you get an indication of what the real car is like, knowing that it's not the real car, right? That's what economic models do. We kind of get some insights into reality, making some assumptions to try to figure out what is the correlation between different goods? What is the connection? If I move this, what happens to this, right? If I move this, holding all of the things constant, what happens to this? So, Lazar? Yeah. So let me grab your laptop there. If I could. You're distracting Zach here so much, so it's just hard to imagine that it's just static on your notes. So remember, if you guys have your laptops, it's only to be used for note-taking purposes, and don't want you to be causing, watching YouTube and some funny stuff. You can do that on your own time. So with this model, we're hopefully getting some insights on why people trade with each other. So that's what we're doing. All right, so we're going to fully specialize each country. So the United States is going to move production to point B and make all food. Japan is going to move production to point B star and produce all cars, and then we're going to allow the two to trade with each other. Okay, so points B and B star is kind of our next step in this. So number one, steps to show gains. Number one, fully specialize in what you have a comparative advantage in. So the USA goes to point B at 8 units of food and 0 cars. I've been listing cars first, so 0 cars and 8 food. And Japan is going to go to point B star, where we've got 25 cars and 0 food. Okay, and now we're going to trade with each other. So number 2, we're going to assume the terms of trade, aka also known as the world price. Assume that the world price is 3 cars for 1 food. Three cars for 1 food. So we can think about this being the world price of food is 3 cars, or if we want to think about it in terms of cars, the world price of a car is 1/3 of a food. So doing that same thing, right, where if we want a 1 over here, divide by 3, divide by what I do to one side of the equation, do the other one. So you can kind of think of these interchangeably, whether you're buying food or selling food. It's kind of where we're going. You can kind of go back and forth. So again, I just gave that to you. We didn't derive it or something. So that when you see the word assume, just assume that that came out of nowhere. It came out of somewhere, but we'll talk more about that later. Now, what are we going to do? We're going to start trading to get back to where we were prior. So to show the gains from trade, each country will show the gains from trade in terms of cars. right, so starting with the USA, what we want to do is get back to having the same amount of food we had before. And then we're going to show how many gains of cars we have. So each country is going to gain for trade in terms of cars, which means get back to 4 food for the USA and get back to 3 food for Japan. So if the US is sitting there with 8 food, what do they need to do on the international market to get back to being at 4? Tell me kind of in real world terms here, what do they need to do? They're sitting here with 8,000 food. What do they need to do? Export or import food? Export how much? 4. They want to get rid of half of what they got to get back to 4. So for the US, for the USA, it needs to sell, which is export, sell 4,000 food and get some cars. How many cars do they get when they sell 4,000 food, knowing that the world price is this way? How many cars do they get? Who's got that one? How much? 12. Who's Lazar? All right. How'd you get it?
Because one food is equal to 3 cars.
Okay. So they're selling 4,000 and it equals 3. So then we just do 4 times 3. So mathematically, we can kind of think about this as sell 4,000 food, and we're receiving 3 cars for every food, which is the price, right? This is the world price of food. And now I did it this way on purpose, so write this down on your papers here. So this is basically quantity times price, or world price of food. Quantity times price is all I'm doing. But now what's kind of nice here is that if you do the multiplication, of course we get the 12,000 that Lazar got, which is great. But also we get the notation correct. So F over 1 times C over F, the F's cancel. And so it's actually 12,000 cars. Did everybody see that trick? I wouldn't call it a trick, but it's just kind of a way to use the math to your advantage, that we're going to get 12,000 cars. So graphically here, we're selling 4, and we're getting not 8, but 12. And so point C is where we end up with trade. Now I want to let the awe and shock and majesty of the market sink in here a little bit. I thought point C was impossible.
It was.
It was by ourselves. Good. So we are outside what we could do ourselves, right? So we've done better through engaging in trade. Through engaging in trade and specializing in what we're good at, we now are outside of our production possibilities. This is called the consumption possibilities curve. The CPC, it shows all of the consumption possibilities available to our country. What is its slope? Higher, yes. Give me a little rise over run action. What is the slope of that CPC line? Somebody other than Jessie, she's been on fire up here. What is the slope? You've got enough information up there to tell me the slope of the CPC line. Somebody who hasn't given me a slope yet. Rise over run, go from C to B. Yeah, go for it. Give me your name again.
Cage.
Cage.
-3.
-3, excellent. I love that you put the negative in there. We're falling 12, down 12 over 4. 12 divided by 4 is? -3, as Cage appropriately said. And so that is the slope of the consumption possibilities curve. How much are the gains from trade? What would you say they gained in cars? Did they gain 12,000? So how many did they gain? Here's where we were without any trade. We had closed borders, right? What would you say we gained? 4. Because we started the process off by, with closed borders, we had 8 and 4. And now we did the trade thing. We specialized in what we were good at and then traded to get back to C. So it's really A and C is what we're comparing with without trade, with trade. So we gained 4. A gain of 4 cars. All right, so let's write that out here. Therefore, USA gains 12,000 minus 8,000 where they started, 4,000 cars. All right, let me pause there, let you guys catch up. Any questions? Something you don't quite see, need a little help with, don't be bashful. All right, give you a little hint and a little incentive to take good notes. This will be on your midterm. You will have to put this together on your midterm in some capacity. So if you have any questions, now is a great time to clear up any misunderstandings. All right, well, let's do Japan. Japan's sitting here with 25 cars. What do they need to do? They've got 25 cars. What do they need to do, Tim?
Sell 15.
Sell 15. So we got to dump 15 cars. Are you sure? What do we need to get back to?
Export them to USA for.
What does Japan need to get back to? 3. So instead of selling 15, we could also think of it differently as how much food do they need to buy? 3. They don't have any food right now. They're sitting up here with 25 cars and 0 food. Our objective is to get back to where they were in the first place to show the gains from trade in terms of cars. So Japan needs to buy, or what do we call that in international trade? Import for 3 units of food. So for Japan, they need to buy or import 3,000 food, but they're on the buying side now. What are they paying with? They're paying with cars. How many cars is it going to cost them? 10? How'd you get that? Because it's on the curve. That's not right. Yeah. 9,000. How'd you get that? And it's Joshua, right? Because why? Good. They're buying 3,000 food, so we need to purchase 3,000 food. So again, we're going to take, let's see, total spent. Let's see, total import. equals quantity times the world price of food equals 3,000 food times, what's the price of food going to cost me? 3 cars, is what Joshua just said. 3 cars for every food. 3,000 times 3 is 9,000. 9,000 what? The F's cancel. 9,000 cars. It's going to cost me 9,000 cars to buy, import 3,000 food. All right, so this one's a little trickier. How much is the gain from trade? How much is the gain from trade if we have to buy 3,000 food with 9,000 of our precious Toyota Camrys? What is the gain from trade? Tim, what did you come up with?
6,000 cars.
6,000, wrong. Mary? It's not 4.
Oh, you only know.
How many do we have currently? I'm going to walk everybody through it. How many do we have currently? We're Japan. You got to be a Japanese person now. So how many do we have? How many do we have currently? No. After, yeah, we have 25. Remember, we're sitting here at point B star. So we have all cars and we're getting hungry. I have 25 cars. I want to buy some food. How much am I going to have to pay? 9,000 of my cars, leaving me how many left over? 16, giving me a gain of... Somebody said it.
3,000 food?
Nope. Who's saying 6,000? Yes. Is that what you said originally?
Wait, I'm
Okay, so maybe Tim, I think you said, I don't know, I'll give you that, I'm not sure. All right, so here, let me lay it all out here. So if I give up 9, I'm left with 16. How many am I getting? 3. There's my new point. There's my consumption possibilities curve. So my point C star, where the Japanese end up, is at 16 cars and 3 food, giving me a gain of, Tim, I'll let you have your glory if that's what you said originally.
6,000.
Okay, 6,000. I apologize if I misheard you. All right, so that is the gain. The gain of 6,000 cars. So, back to our list here. So therefore, the Japan gains 16,000 minus 10,000 equals 6,000 cars. All right. So we have 2 winners. Japan's winning, the United States is winning relative to not doing anything themselves. The same thing happened for Japan that happened for the United States, is that all of their consumption possibilities are now outside of what they could do themselves. They were the hot shots. They were better at making cars, they were better at making food, but yet they find it beneficial to trade with us fat, lazy Americans. Yay, America, right? We're saved. So this is really good news, by the way, for the whole globe. If you are a very, very poor country in Africa, this is great news. Is that country different than the United States? Remember, that's how we started. Is any country in Africa different than the United States? Yes, there's going to be differences, right? That's how we started this whole thing off. So differences of countries creates what we just did. Every country has a comparative advantage in something. That is really good news for the whole world. It means that no matter how resource poor you are or whatever your situation is, there is mutually beneficial gains for you to trade with somebody around the world. So that's one of our big conclusions we get here. That's really good news for poverty around the world, and it has been, by the way, for the last 30 years. The reductions in poverty, economists study pretty closely, are attributable to countries opening up to trade. That fact alone, getting these win-wins, is pulling more and more countries out of poverty. So, key point. Every country, no matter how poor in resources or other things, every country has a comparative advantage in something. This means that international trade is low-hanging fruit. Put that in quotes here. Low-hanging fruit in fighting poverty. All right, any questions or comments so far? What's the slope of the consumption possibilities frontier here in Japan? You've got enough numbers up here to do a little rise over run. What is the slope of the CPC? Yeah.
Negative 5.3.
Negative 5.3, no. Yeah, negative 3. So down 9 over 3. 9 divided by 3? Yeah, and it's easy to make that mistake. Like some of you did it too. I've done it in the past on tests when I took this stuff. So it's not hard to get, so you have to be kind of diligent of doing the right rise over the run and the right numbers, and don't think 25 or something like that, but you're just following that line, and so the slope is negative 3, which makes sense that both countries would have the same slope, right? That was the shared thing. The world price of food is the slope of the consumption possibilities frontier. The world price of food was 3, and so this is a shared thing between the countries. In fact, what would happen if the price was 4? Would both countries still gain? Would both countries still gain if it was 4?
Because US is 4, so wouldn't it just become our average slope?
So this slope was 2. This slope was 5. And so as long as it's somewhere in between, we're going to get the same result. Both countries would gain overall. But who would that favor if we instead got 4 units of food instead of 3? Who would be getting a better end of that change? Japanese or US? Japan, right? So now they give up their 9 and they're going to be out further. But that doesn't take away from the fact that the US, this would tilt in, but there'd still be a gain. So what we've done is we've set up a marketplace where the price, the world price, can vary anywhere in between 3 and 2, and there's a winner. So let's put that as a little extra note. The world price of food, somewhere between 5 cars per unit of food and greater than 2 cars per unit of food, which, let's put a little asterisk up here to remember that this was Japan. Anywhere in between here creates gains for both countries. Creates a gain for both countries. All right. So we showed the gains from trade, but there's actually a problem here in the sense that this couldn't be reality if there was only these 2 countries. So there's nothing wrong with what we did. We showed the gains from trade in terms of one good. In fact, before I forget, let me give you the challenge problem for homework here. So you guys do this homework problem, come in tomorrow, show me your sheets, and everybody who does it gets an extra credit. Everybody who does it right gets an extra credit question. Show the gains from trade, an extra credit point. Show the gains from trade in terms of food. So in other words, calculate D and D star. Don't do it now because I'm going to get into some other stuff that you need to know. But for extra credit, calculate the gains, so extra credit. Due tomorrow, calculate the gains from trade for each country in terms of food instead of cars, which means you're looking for points D and D star ultimately to show the gains. And you guys might not want to do this on your paper, but basically, what's this number and what's this number? And then you can calculate the gains the same way in terms of food. Which is highlighting where I wanted to go next, is that this can't be the real world imports and exports. Does anybody know why? Why can it not be possible that point C and C star would actually be the trade amounts? Jesse, you see it?
Because there are so many other people in the world who can trade.
No. Just this model alone. If Japan and United States were engaging in trade, it's not possible for the United States to be at point C where they're at 12 and 4, and for Japan at the same time to be at 16 and 3. That's not even possible. Why? In that example, point C and C star, how many cars are being consumed by the globe with only our 2 countries? How much is USA doing? At point C. Number of cars, 12. How many is Japan doing? 16. 12 plus 16 is 28. How many cars are there in the world? Under our model. How many cars were produced? How many cars were produced? No. At our trade amounts here, how many cars exist in the world? Simon, I think you'd be brave. Remember, sometimes I give extra credit for bravery. 25, you're right, so you don't get extra credit. If you were wrong, I was going to give you extra credit. There's the incentive system getting messed up again. Incentives matter. Simon's right. So kudos to Simon, just no points. But good job. There's 25! Isn't that where we started off? So there's no way we could be at 12 and 16. So there's a difference between showing the gains from trade and the actual post-trade amounts. What has to happen, you'll see this in accounting. How many of you are in accounting class right now or had it? Debits have to equal credits, which basically in this context means what the United States sells to Japan is what Japan must have purchased from the United States, right? And it has to hold. So imports must equal exports. All right, so let's put that note down here. Important note after our extra credit. Let's put on here, quote, showing gains in terms of one good. By the way, how do we normally show the gains in the real world? What do we use as our measuring stick? I'll give you a hint. Rub my fingers together. Money! And specifically around the world, the US dollar is the global currency. So most of the gains from trade would be shown in US dollars, even if you're in Argentina, or if you're in Germany, or if you're in France, right? The gains from trade on when people are looking in global markets would be showing the gains from trade probably in terms of the US dollar because it's convenient, right? It's convenient, and the United States is still the global leader in imports and exports, and so that's part of why they have their dominance around the world as the global currency. But really, it's a matter of convenience. It's like, well, this would be tough if we show it in terms of euros or in terms of Argentine pesos, and then we have to do the conversion. If everybody just kind of uses the dollar, it's a lot easy to say, oh, well, France gained more than Argentina with that deal, right? So it's an easier measuring stick. So that's what we're doing here, is showing the gains from trade in one term, in terms of one good, is different than actual post-trade imports and exports. For actual trade, the two must be equal. For actual post-trade, imports of, let's just say Japan, one country, must equal the exports of the other. What I sold to you is what you bought from me. Oh, this word, actual, yeah, for actual. So for actual post-trade amounts, imports must equal exports. So we'd be somewhere in between here is where we'd actually solve the problem. All right, so we're going to conclude here with where we'll leave off, or we'll start tomorrow. Kind of crazy. We're going to put 3 graphs side by side. Hold on to your hats.
What we've done before.
We're going to put, what did I say? France over here. And we're going to put Argentina over here. France over here and Argentina over here. And in France, they have fine cheese. Am I right, my Frenchmen? All right, so we only have one Frenchman here today, right? Okay, and my other friends, two French guys are gone. All right, so in France, the cost of cheese is, let's say, $2. We'll measure it in American dollars, like I said, just because it's kind of convenient. And in Argentina, they like their cheese too, but in their country, it's not as conducive to making cheese. And so cheese is $4 in their country. Again, converting all their currencies back to American dollars. So this is cheese in Argentina. This is cheese in France. Who do you think has the comparative advantage in cheese, according to these numbers? France or Argentina? Who's got the comparative advantage in cheese? Paige? France, because they can make it cheaper, yes. So the price is lower, which means the cost must be lower, right? So the costs are lower, the price are lower, so they have a comparative advantage in cheese production. Argentines still make some cheese, but it's at a higher cost. So what is France going to do? Is it possible that they could make a deal with Argentines? Yeah. If they could get $3 on the world market, would they want to make that deal? Yeah. If these guys could get cheese for $3, would they want to make that deal? Yeah. That's where we're going tomorrow. We'll pick up there.
Xbox is supposed to say USA or